This practical is based on PLC to PLC communication using Ethernet IP. It is practical. The objectives are use the Ethernet IP to communication between two PLCs and how to configure the PLC and your computer and network switches to initialize the communication and use CIP symbolic client messaging functions to communicate between the PLCs. The apparatus will be using two micro 20 PLC units and 4-port network switch. You need to use two laptop computers, one for data transmission and one for data receive, and DC power supply to power your PLCs and the Ethernet switch. Some push buttons and lamp indicators to display the status of the code. In the pretest, you are asked to sketch the block diagram of how two PLCs can be connected for data communication using Ethernet. So here you can refer the reference material provided in the LMS, which gives you the instructions how the hardware setup is done. In the procedure, there's a problem. This is a simple automated problem which we are going to run in the lab environment, simulating using push buttons. So if I explain this problem, in automated project, it is required to monitor the number of vehicles inside the parking lot using PLC-A. This number is then transmitted to distance PLC-B using Ethernet. You may use two push buttons at PLC-A to demonstrate the vehicle counting for entering and leaving, and also use a data send push button to initialize the data transmission manually. A green light should be lit at PLC-B if the number of vehicles in the parking lot is less than 5, and a red light should be lit when this number is greater than or equal to 5. So basically at PLC-A, you have to use a counter to count the number of vehicles entering and leaving, which can be simulated using push buttons, one for entering, one for leaving. And also you have to use another additional push button to data transmission. Once the data transmission push button is set, it will transmit the data from PLC-A or the counter value using the Ethernet. At PLC-B, so you have to read the data coming from the Ethernet and display it, as well as you have to use these light indicators to display the status, whether the number is less than 5, whether the number is higher than 5. Step number 1 will be displaying your input-output assignment for your push buttons and the lamps for two PLCs. Then you have to write a code for data transmission and data receive using the Allen Bradley Micro 800 programmable controllers, and using this manual code getting started with CIP client messaging. And similarly, you have to configure PLC-B for data receive. Then you have to come back for hardware setup and testing. First step is to disconnect the AC power from AC mains, and which disconnect the power to the PLCs. Then you can connect your push buttons and lamp indicators in PLC A and B. Then you have to connect two PLCs using the network switch using Ethernet cables. Then your lab setup should be checked by your instructor. Once it is verified, you can power up the PLCs and Ethernet switch. Then you have to assign the IP addresses correctly to your two PLCs and build and verify your program. Then you can download them and test it. In the observation section, you have to attach a photograph of your test setup with a clear view of PLC A and PLC B and the Ethernet switch. Then you have to take screenshots of your ladder diagram before downloading, and then display the input-output variable list in two programs, transmit and receiver. While the run mode is enabled, get screenshots of ladder diagram for different test conditions as below. So at PLC-A, you have to take a screenshot when the up-down counter is enabled, how the variables are updated, when the data sent by button is pressed, and you have to display how the COP and message CIP generic function blocks are updated. In the PLC-B, you have to display the received data from PLC-A, and operation of light indicators based on the data received. This is the application note you have to refer for configuring your PLCs and writing the ladder diagrams. This is message between two micro 50 using Ethernet, and document number is this one. And here, this is how the hardware setup is done. You have PLC A and PLC B, and they are connected using the Ethernet. There could be a number of other PLCs connected to this Ethernet switch. And you have to correctly configure the IP address and subnet mask of PLC A and B. So the PLC A and B IP addresses are given in the PLC panel board. So you have to feed that correct value to here. So you should not use a same IP address for A and B, then that will give you some problems in the code. So these IP addresses are different depending on the IP address given in the PLC panel boards. You have to assign them. So how to assign them? So first you have to create a project in the connected component workbench. So open your project and select the correct PLC, whether it is micro 50 or micro 20 PLC. You have to select the correct PLC in your project, and then go to the controller and go to the Ethernet. Here you can add the IP address and subnet mask for PLC A. Then you have to import the COP or copying function block to your ladder diagram, and then equal function block, then message CIP symbolic 1 function block. These 3 function blocks has to be used. Then you have to correctly assign the variables for data transmission and receive. So basically, in the Ethernet, when sending the data, so the data packet will be something like this. So we have a preamble which gives you some indication of the data going to be transmitted, and this is SFT's start frame delimiter, and then TA is destination address, SA is a source address, and the length of the data packet, and depending on the type with the IP version 406, then the MAC client address, client data, and PAD, and error correction. There could be some extensions. So you can refer the messaging packets and frames using IEEE standards. I'm not going to cover them in detail, but we are coming back to our lab manual. For additional details of these functional blocks, you have to use this micro 800 programmable logic controller general instructions. Here, all the details of the function blocks, COP1 and message CIP symbolic 1 function blocks, and their details are available. So if I explain the function blocks, first you have to enable the COP function block. So here you have to use a normally open contactor, which can be linked to your whatever the data sent button. So if that push button is sent, this will be enabled. So you have to assign these variables. First one is source data. So value to write is the counter variable in your PLC A, which carries the information about the number of vehicles. So value to write should be assigned to double integer, which is 32 bits or 4 bytes. The dimension is single array, so you have to assign it 1/1 single dimension. Then source offset, that should be assigned to 0 because we are not offsetting the data. Then destination data. So destination data, we type it as A_data, and you have to assign it to unsigned short integer. Unsigned short integer is like 8 bits or single byte data, and so since this is 8 bits into 4, or like 4 bytes, and we are splitting this double integer into 4 bytes because a data is unsigned short integer. It is a single byte and this has 4 bytes, so we have to somehow crop them. So you have 1 2 3 4 bytes. This is 32 bit, or like so which carries, one is 8 bit and this one is also 8 bits, and like that double integer is copied by splitting into a 4 uh, bytes array. So COP function block uh, basically does is it will crop this double integer into 4 bytes because this message CIP symbolic one which only accept bytes for data transmission. So value to write is double integer. We split it into 4 bytes, and that is copied as e data. And destination offset we set it to 0, and length is 4 because this has 4 bytes. So we assign it to 4. And swap is set to true, which means you are swapping the data. So even though like whatever the 4 bytes you are assigning, this is the highest one and this is the lowest one, when you sending it will be swapped. So this one copied here, and like that this one comes back to here. So swap has to be enabled according to the instruction of lab manual. So you have to keep it as true or 1. So more details are available here. You can read them. Byte swapping, what is that for, and etc. Then like if this copying function block executed, this one enable out will be true, as well as this status will be set to 1. That is copied to COPSTS status. Since this is a variable, we cannot directly couple it to this this message CIP symbolic function block because it will only accept some sort of contactor input. So in that case, we have to compare this Boolean type data with 1. If this is 1, this equal function block will energize this right value coil. So if this is true, that will activate this normally open contact or close this. Because why we are using this one as a middle function block, because you cannot directly copy this to here. Instead, we have to, this is also Boolean type, compare it and energize this coil and then close this contact. Then this data will be sent, copied to message CIP symbolic function block, which handles all the data transmission. Right? This copying function block we are used just to split that 32 bytes double integer or the counter value into 4 bytes, and then that 4 bytes is fed into here. This will handle the data transmission through the Ethernet. So you have to correctly configure this function block. You have to create 3 data types, and the final one is data. You have to assign it to a data, which you have already defined in your global variable list, unsigned short. And here you have to create this a underscore control config. It's the name of the variable, and assign it to control config, and a underscore symbolic config is assigned to symbolic, and target config is directed with a underscore target config. So once you create these variables, you have to go back to this global variable list and correctly assign it to the variable type. A underscore control config should be selected as CIP control config type. A underscore symbolic config should be selected as CIP symbolic config. A underscore target config should be selected as CIP target config. And A data will be the same, which we have defined here. There's a small mistake in this PDF because A data 1, it should be corrected to A data, which the same thing we have used. This is like A data 1 is something which is not relevant to this one. So if you have A data, which is defined here, you can directly link to here. Right. So a control config, CIP control config, you have to provide this trigger type 300 milliseconds. And in the symbolic, CIP symbolic, since PLC is sending data, you have to assign it to 1, right? Write data is set as 1. Then you have to put this tag, which is UDINT from A. This could be any name that you can put it as a label to identify your data. So UDINT underscore from A, I will keep it as the same and make sure you say the maximum characters that can be there is 80. The data type should be selected as 200. There's a list of the numbers. If you use unsigned double integer, it should be 200. Although there's a small, because you have used DINT, and here it is unsigned DINT and 200 is used, not this double integer. So you have to use 200 here, then only it will work. You can use this as a UDINT as well, it should work, right? Then the target config, where your target address, which is the address of the PLC-B, and that should be feed with 4 comma 4 is the port number of the PLC. If you go back to this PLC, there are different ports. This is Ethernet port, and there's a USB port, and there's a RS-232 port. There are several ports available. Port number 4 is assigned to Ethernet. That's why we are using number 4. If you look at the catalog of PLC, each port has given a unique numerical character. For the Ethernet, it is number 4. So that is why we are using it as 4 comma the IP address of the PLC-B. And these values set as default 1, 0, and 0. Then basically your PLC-A code will be done. Then you have to come back to PLC-B. Again, you have to create a new project in Connected Component Workbench and select the right PLC controller and go to the Ethernet settings and configure your PLC-B IP address. And then you have to just go to the global variable list, because PLC-B, we don't need to write any or use any function block to read the data. So you have to create a label or the tag name as UDINT from A, the same tag we have used for sending the data, that is carrying this information or your counter value or the number of vehicles as like a label. So you have to write the same name in PLC-B global variable list and set it to UDINT, unsigned double integer. Then when you execute the code, if there aren't any errors, so when you press the data send button, so the counter value, here there's a number is displayed, which is not the value that you should see in your PLC, because you should see the counter value or the number of vehicles is copied to this value to write. And then if it is executed, this should be 1, and that is compared here. and that will close this write to value, and that will enable this message CIP symbolic function block. And this is the target address, and the data will be sent. If there aren't any errors, this should look goes false. The status is if there are any errors or not. If there aren't any errors, this becomes false. If there are any errors, there is an error code. You have to go to this error codes status, and in page 167 there is an explanation of each. If you have a number here, you have to refer the correct number and see in this lab manual what are the status or the errors. So when you send in the data, your PLC A should look like that. This is a PLC-P. In your global variable list, you should see the data coming from PLC-A. For light indicators, you can create an additional ladder diagram for comparing the number of vehicles, and based on the received value, this global variable, you can compare it and control the indicating lamps. So that's all for this practical, how to do the hardware setup and program and function block configurations. You can read this application note, and additionally you can read this micro 800 programmable controller generic instructions, where you have this explanations of COP and symbolic function block. First, you have to go to the connected component workbench and create a new project. So you have to name the project name. So it is now named as send data. Then go to the controller and select the controller type, micro 20 QPBR. Then in the controller, go to the Ethernet and select the IP address configuration and provide the IP address of the transmitter site PLC, and then set this up at mask. Then we can create a new ladder diagram. So now we are opening the ladder diagram. Then as shown in the application manual, we have to create the program that is responsible for transmitting the data. So this is the input, digital input 00, which is linked to the push button that can be pressed for sending the data. And now we have imported the COP function block, and you have to parameterize the appropriate inputs. So this is the source value to write, that is unsigned UDINT 32-bit value, unsigned double integer, and source of set is set to 0, and 8 underscore data is the destination data, and destination offset set to 0, and the length of A data is set to 4, and the SAP is set to 0. And the status of the COP1 function block is named as COP1 status. And value to write, you have to select it as unsigned double integer, and the A data should be selected as unsigned short integer. So the status should be selected as unsigned integer. So as you know, like we have to check the status, whether if it is 1, we have to energize a coil by using the equal function block. So which is basically compare the status of the COP function block against the Boolean one. Then we can add the coil and we can name it as write data. Then in our next run, we can add the symbolic function block. Now it should be enabled using the write data, normally open contact. Now we have to parameterize the message CIP symbolic function block. Now this is first one is a underscore control config. And the second one is symbolic config. A underscore symbolic config. You can provide any name that you wish, but you have to select the appropriate data type. And the third one is target config. And finally, the data should be a underscore data, which is coming from the COP function block. And the status is for the error. So we can visualize if there's an error by looking at the error code, you can debug the code. Control config, symbolic config, and target config should be selected with the appropriate variable type. Otherwise, it will give you compilation errors. And CIP status should be the same type. And write data, you have to specify in the local variable list. So a data should be like a one-dimensional array and with 4 elements. And value to write is UDINT with the one-dimensional array with a single element. In the message CIP symbolic one, these variables has to be assigned with the appropriate value shown in the application note. So the trigger type is 300 millisecond. And since we are sending the data, you have to specify it as 1. And the symbolic name read write, that is the tag. You can name it as any name. Like here we have labeled it as a underscore data. It could be UTINT from PLC as shown in the previous application note. And the symbolic data type, since this is UTINT, you have to configure it as 200. Destination path is the PLC-B address. So this is 4 is the port of the PLC-A, which is responsible for Ethernet port. And this is 10.10.25.6 is the PLC-B address. And we have to set these values as the default values. Now your configuration is done. Then you can build your code. Here there's an error in the code. You have to go to the local variables and data should be selected as a underscore data. So that was the error. So you have to select it as a underscore data. Then the compilation error will goes off. Now our project is successfully built. You can save and then upload this code to the PLC-A. Now you can create a new project, name as the receiver for your PLC-B. And select the appropriate PLC and add to the project. And you have to correctly assign the PLC-B IP address here with the subnet mask. Now In here, there's no coding has to be done. Just name a global variable called a data that is used for as the tag in the PLC A and select it as UDINT. So whenever data is received to PLC B, that variable will be updated. So now you can compile the code, and if there aren't any errors, you can upload it to your PLC B. Then you can check the transmitting and receiving the data.